Možná, ale opravdu možná bude potřeba mluvit trošičku víc nahlas, protože ta Jabra není tak citlivá asi, nebo nevím. Ale já už to mám tady vytažený na maximum a stejně furt je to takový jako...
Okay. Se budu rozespívat vedle.
Takhle super, takhle super.
Jsem to slyšela. Zdravím všechny na prezentaci frontendového frameworku Svelte a jeho pre-renderovacího engineu Supper. Já se jmenuji Tomáš Řezáč, kdo mě nezná, jsem tady seniorním vývojářem. Actually, no, I realized that I should speak in English, so again. So we are presenting the front-end framework Svelte and Supper. My name is Tomáš Řezáč, who knows me, and beside introduction to the framework, showing the pros and cons, because it's not only bright future, it has also some flaws. I will try to answer this question, or maybe we all together after some discussion at the end, whether this is the type of frameworks which will come in the future, because it's quite different to what we have now. I differentiated the two colors. Svelte red, Supper blue, because they are different counterparts in the framework, so later in the presentation you will be able to distinguish whether I'm speaking about only one or only the other, or if it's white then I speak about both together probably, and we will see what is what exactly. So we can move on to what is what. So it's declarative framework. Declarative framework is something similar, like we know from React, Angular, Vue. These are kind of frameworks which has kind of its own language. It's trying to build complex app. It's not just moving things in a DOM like with jQuery. You simply declare what you want and you get it. The Supper is the builder of app, because Svelte itself doesn't build app, it only builds components. So Supper take care about stitching the things together, pre-rendering them on server on initial request. So it's like builder and pre-rendering, like the other frameworks also have. And it has its own router, which then after the initial pre-rendering run in the browser and is able to connect URLs to components. So, what's the difference between Svelte and the other frameworks? As I said, it's somehow different, it's still declarative, but what are the main differences? It's actually not a framework, it's just a compiler where you write some code and you get some total other code, and you don't, what's the main point, you don't get the framework itself after compiling. React or Angular are actually kind of compilers as well, because they don't, you write JS6 or you write in HTML with some mustache stuff in Angular, but at the end you just get instructions how to create the DOM by JavaScript, not HTML itself. It has no shadow DOM compared to the other frameworks, so you don't need to deal with optimization on your own, deciding where you should pre-render something or not, where you want to avoid. So this is something which is not nice on, for instance, React. When you want really to optimize, you want to take care yourself. The framework won't help you much. And it has no framework bundle at the end, because as it compiled to just something maybe similar to jQuery or some like native instructions, you don't need anymore the framework, because the compiled code works like tree shake to the minimum. And if I say to minimum, it means that when I use some feature, some animation, it will be in the bundle. It will be in the bundle of the particular component or the particular page, but it will not be part of the whole app. You never load the whole app at the same time. You always load stuff on demand. Every single page by default is loaded. When you click on the page, then you will get new piece which the supper will give you from backend. So every single initial load on any page of the app is like super fast, super small bundle. And every other is then loaded on demand, or you can handle it yourself. You have actually, I said that it has its own router, but actually you don't have router definition as we know it from the frameworks. When you decide in a code that you tell when you enter this URL with this dynamic part, you go somewhere. It's only done by how you put your files in the folder structure. If you have the router folder, you put there another folder which is called block, then under URL block / something what's inside the folder named block will get the URL. So the URL is actually derived from the structure of the folders, and the folders itself can have some dynamic placeholders in the names. Now what's the similar? It's component based like all the famous and fancy framework today. It's reactive, so it has like two-way bindings. It has stores, so you can share data among components between just connecting each components to each other with shared data. If you want, you can. If you don't, you can always use stores. And it has syntax like framework, so beside or declarative framework. So you can imagine you write React app, but it's compiled to something totally different than what you know now. So why all of this? Why someone created such a framework? Because we want the declarative way. There are many people who do the declarative way of using React on apps which are actually totally not good for React to be used in. Like your personal homepage probably is not full of interactive features dealing with sending data from one component to another. You could use some super simple server rendered engine, Ruby on Rails, some PHP, Symfony, whatever. You don't need a framework for it. But unfortunately, a lot of developers nowadays do it. They just use React, they use Angular for things which are not apps, which are web frameworks. So this come here. So we don't want to process all the code because it's not only about you are downloading big bundles, but on the initial load, if you have 200 kilobytes of JavaScript, it took like 1 second on quite fast computer to the computer just go through all the code, do the hoisting, decide what needs to be kept in memory, how to deal with the stuff, and so on. So processing of all the JavaScript on the first load is quite demanding, and on mobile phones it can take 10, 15 seconds. So it's not only about the bandwidth. And this is what it's bringing in. You have the declarative framework, but you don't have these big bundles. You don't need to process code, which is not necessary. We also want this reactive binding magic, which is in all the frameworks, but we don't want the slow apps, which are often coming with it. Like in the Shadow DOM, as we will see later, it's not that fast. Shadow DOM is way how to deal with the architecture of like state-driven machine, which do the diffs on the virtual DOM. So it's way faster than normal DOM. So it makes sense, but the Shadow DOM is not like addition. Is nothing would make it faster. It just solve the problem which these frameworks have. But here we don't need it. And we want even more magic, like computed properties, where you compute one property based on some other properties which change, and you wait for any change and give some result. But we don't want to write a lot of code to handle this, which unfortunately in a lot of frameworks you have to do. So now about the compiler. It's actually create code which directly changes DOM. As I said, similar like native JavaScript, jQuery. But writing manually the direct DOM changes often come with some side effects, which you don't know when, change what, about the order, that you forgot that likes to trigger some side effect, and there are many, many bugs. And with this compiler, you just don't care. It's done, it always works as perfect as in any other declarative framework we know. Fortunately, the code which is compiled, until it's minified, it's pretty well readable. So you can create your web component for use like outside the app, just to use anywhere in your Angular app, for instance, and you pretty much understand what the code which was compiled is about. And you can even modify it manually later. As I said, or that it has own computed properties, and it's deal with the side effects, and you will notice that there is something like it. So what's like under the hood? We have the technologies we already know. We have a Babel or ECMAScript Next. Unfortunately, in the base setup, there is no TypeScript support. It can be switched, but it's not like optimal because it has issues with linting, as the syntax of what we write in the framework is actually, as it is compiled, it sometimes comes with some additional sugar syntax which doesn't exist in normal JavaScript. So then the linter, or actually it exists, but it does something different than it should do normally. And with JavaScript, it works quite fine with linters. With TypeScript, it can be quite a challenge to get it running properly, so it's not by initial. It also starts with CSS, but it can be very easily switched to any other transpiler or preprocessor. It uses this syntax, which is not the mustache syntax or this like library for doing so, with its own compiler which deal with it. So as I said, it has some weird syntax stuff. So first of all, similar, I guess, to Vue, we have all the three things of component in the same file: JavaScript, HTML, CSS. And until you do some imports, which import it manually from somewhere else, then you need to share all in one file. But it's just for me, from my use cases, I have never struggled with like super huge components where it's issue. We have some convention that the component itself simply, its name is derived from the name of the file, similar like I said about the routing. So it has capital letter, that means that its component is called as well. So you just import this file as some component, and you just use it in your markup, and it's rendered as the component. Now the weird things. We have some special stuff about let, which actually, when on the root level of the component, declare variable with let. That means that if you use it in a code in template, it's already like real-time binded. So when the variable change itself, it will be reflected in a template out of the box. And just about declaring variable, nothing else. If you declare it, you don't use it in the template, then it's not compiled to this binding, so you don't generate extra code. It's like super smart to knowing what it's really need to compile or not. It has the export, which if you use before let, export let prop, then it's actually prop, which can be like input for the component itself. So when you have some component in your HTML, you just then set prop equal something, and it will be actually propagated to the component. So it's, as I said, weird syntax which doesn't exist in JavaScript, but the compiler can leverage the syntax and somehow use it. And it has something even weirder, which is this syntax with dollar double dots, which is actually totally normal JavaScript syntax, probably no one ever used, but it's pointer when you have some while cycles and so on, and you have nested cycles, and you need to break from the cycle at some point, and then you need to know whether you break the inner cycle or the outer cycle, and this is syntax in JavaScript which tell you where to break, like where to continue after the break. But here it's leveraged as something which I would say they call it like reactive. I would say it's actually computed properties. So you declare A equal B plus C, and whenever B or C change, then the A is again computed out of the box. So if you use A in your template and you anywhere in your app change B, then A is also recomputed and changed in the template. It's super easy syntax, as it's kind of tricks the real JavaScript. You use very simple way of doing these computed properties, subscribing, like doing like similar something like streams and so on. So probably it will be way easier to find in some examples. So if I find how can zoom in, which somehow doesn't work well. I tried, but doesn't really work in the full screen mode. So as I said, this is the let just says it's bindable in the template. One example, you can have the same in attributes. You simply use your bracket somewhere in attribute and it's work the same. You have example of some styles, just normal styles as you would say in normal CSS. The difference is that they are scoped to the component itself. So if you have nested component, you see that you simply imported it and then use it here. But the nested one, which has also P, is not affected because it works similar like the shadow DOM components, which simply use some prefixes on the classes, similar like other component frameworks do. Here we have the examples with the reactivity, for instance. So you just says that quadrupled is doubled, and when you just click, it's like out of the box, this quadrupled is shown, and so on. So there are many things. The great, as I said, is that if you don't use the feature, it's never compiled to your bundle, it's never used. Here is the export let in the next step, where you simply use it as a prop of the component. We have all the syntax we know from other frameworks, like for templates, if, else, each blocks, or for each, some iterations. You have event handlers, you have emitting the events to the higher component in the hierarchy. You have, I would say, everything you know from the other frameworks, and you have something extra. You have some stuff which in the other frameworks would take too much size in the bundle of the framework that they simply just avoid it. You implement it as you want if you need it. But here, as it is not part of the final bundle, if you don't use it, they can add you a lot of different syntax sugar. They can add like super cool animations. They, I don't know, deal directly the stores. If there is some animation example, probably not. But it has even animations like transforming one DOM component to the other, which like changing the parent element where it goes. So if you have div and inside there is a span, and you have p, and you do the animation of the div or the span from the div to the p, and simply during the animation change the real like wrapper in the DOM, not only visually on the screen, but in the DOM, which can be extremely useful in like drag and dropping stuff from one to each other and stuff like that. So I wouldn't spend much time here because just imagine it can do more or less everything you can do in some other frameworks. So no idea what this do actually. Okay, it has some transitions for gallery. Like you can do really a lot of things. I wouldn't say it's limited any way from the other frameworks, so the architecture is not limiting. Here what I said with like transforming in the DOM, so it's not only animate the stuff, now it's in this wrapper instead of the old wrapper, and so on. It supports directly SVG in, so you can write SVG as HTML and you can bind everything to the SVG directly as you would do in HTML. And many others. You have slots for telling that some component had different slots where you want to like transclude the other inner component and so on. So it was about the functionality. It has more or less everything plus something more than the other frameworks. So now check the speed. There is a app I didn't do, it's just Game of Life, which has one implementation in React, one in the Svelte, and it has total same functions for the computation of the like how they behave, what are the rules. It just have the different engine for showing the stuff in a screen. So because the framework which I use for the presentation somehow can slow down the computer because it's cache all the stuff in memory, and so I just reload, and because it's not on professional hosting, it takes some time. It's always that after some time it gets to sleep and you need to wake the server up. Then it's faster again. So next load will be super fast already. Okay. So I will go for the fastest what I can get. I get this template with some rules and what's happening, and now what does it do in React? It's not limited by some like set interval which goes for the frames. It just goes as fast as the DOM is changed. Now I go for the next one, which is done in Svelte. And I even don't need to reload it because it will be hell too fast already. And this is the difference. It's like 10 times faster manipulating the bindings in the DOM because it doesn't need the shadow DOM, it doesn't need the diffs, it just works without it. So that's for the speed. So the good part is the speed, as we saw, it's like super fast. It's a compiler and it hints you when you compile. So something what can happen in some frameworks that you get the hints too late, maybe if you do production build, but not before. Here you get it straight away, and it can hint a lot of things, not only that there is a bug in the code which just throw error. It can tell you that your picture doesn't have the attribution back or like some typo, or that there is some bad contrast on elements, or a lot of different accessibility things and stuff like that, because the compiler really have to understand what the code is to compile it correctly. So it's just side effect bonus that it can know what the code is about. It can be used as standalone components. You don't need the supper part, you just need the Svelte to create web components if you want. It not necessarily must be this like JavaScript component by default. It can do the wrapped shadow DOM one. It has, as I mentioned already, a lot of built-in functionalities which are not in the other frameworks by default, and it's just nice bonus. And again, if you don't use the feature, it's not in the bundle. What are the bad parts? Because they are. So it's misusing the JavaScript syntax, as we already saw, and I'm not sure whether it's good for the beginners which just learn something what's actually not the language which is presented. It's presented, this is written in JavaScript, but actually it's not. It's something more like Svelte script. It doesn't have the support for TypeScript and Sass. With Sass it's easy to turn on and it works just perfect. With the TypeScript there are some struggles, and it's probably one they already know about it. The author would like to have it there, but he is not feeling that strong in TypeScript, and it's not that simple that you just pre-compile the code to JavaScript and then to Svelte, because then you can lose some information. So you need to create your parser directly parsing TypeScript if you want to do it correctly. And maybe the worst thing from my perspective, why this is not enterprise ready, even if this is like third version of the Svelte, which is like way more extensive and doing more things faster than the before. That's maybe why there was such a hype about the version 3. Before, no one really cared about the framework. Now it has like, during 1 week, when it was released, the version 3, which is, I don't know, 2 or 3 months ago, it had from few hundred stars on GitHub to something like 20,000 during 1 week. So it was really like everywhere, everyone was speaking about it. But yeah, we will probably wait for version 4, which will come with some like syntax or TypeScript, which will really force the developers to write in some way, which then when another developer comes will understand the same way, because now it's like Wild West, you can do whatever you want. It will work, but maybe someone else will not be able to read it correctly. And with that, it comes that the apps can be quite hard to maintain. And the final code can be actually bigger if you have like super huge app, which some kind of apps we develop here. In some cases you don't care, because as it is loaded on demand, page by page, it's never the single page is so big as the whole React, for instance. But if you have the request that you load the whole app at once, you can, after the first load, simply trigger to preload every single page, even if you don't use it. And then the generated code, if you have hundreds of pages, can definitely be bigger than the framework, because always the single instruction to the DOM have simply some overhead, because they cannot rely on the framework itself, which can make things like some abstractions, which are here as well up to very small level. So the supper, it's the pre-rendering part, as I said earlier, or in the beginning. It works like in the other framework. You just hit the URL, the server check what's on the page. It has actually access to the session, which then can be transformed to some JSON and pushed to the page as well, so you can later use the data from the sessions and so on. So it's quite mature, I would say, and I haven't had any issues with it, that anything failing. It has some specific syntax how to avoid stuff like calling window, because it doesn't exist in Node and stuff like that, but all the frameworks which have pre-rendering do that, so I would say it's quite similar. It has these dynamic parts in URLs. You can have like multiple dynamic parts in the URLs of the files which are in the folder. Maybe I can later show some real example to imagine it easier. It has quite easy way how to inject like metadata, and by this I mean the metadata of HTML, which are then used by Facebook sharing or whatever. That in a page which is in the folder structure of the routes, you simply inject some special HTML tag metadata, which is like in different how to say, scope, and it's not rendered to the page, it just passed to the data to some template, which then show it in the real generated index file. It has layouts, so if you have the routing, you can decide that some parts are always there, like your menu. You can have your nested layouts, so it's come with the similar functionality. And why this is probably doesn't look like something what should be in the supper, because it's not really need the relation between pre-rendering and layout. But as I said, the Svelte is only about creation components. So everything what's like above it, which is layout as well, it's already in the supper builder extension. It has quite interesting way how to prefetch the stuff. As I said, every single page of the app is like its own bundle, because none of the bundles need the framework. So there is no difference whether you put everything together or everything separately, because everything together is just sum of all the pages anyway. And pages are actually prefetched by default. When you are in an app and you hover over some link which goes somewhere, at the time when you hover over, it's already prefetched on background the things, process the JavaScript, where there is mostly a little, and it's, if you have good server, it's so fast that before you actually hit the link, it's already in the browser. So it's like super fast. If you want, you don't need to wait for the hover. You can program any behavior you want. So for instance, you can just go through the DOM after the page is loaded, check where are the links, and preload the stuff as you want, maybe some links yes, some not, and so on. And the pages which are preloaded from the server can also have, based on the dynamic part, if you preload something which has like comment 25, the page which is preloaded before you even hit the page of the comment 25, you preload the page, and there is just another special block of JavaScript syntax which is triggered before the stuff is loaded, which is called, it can take the number 25 from the URL, load all the data needed in the dynamic page, and do something and somehow change the DOM, which is later rendered. So it's like that you can load anything, preload even dynamic data, not even kind of static pre-rendered pages. And what I also said already, that every page when it's first loaded gets its session to some like kind of store, which is very simple way of presenting, I don't know, Redux. It has very similar use cases. You can even, based on some rules, create your own stores. So you can create your own copy of Redux working with the Svelte, which is also working on the server side. So when to use it? Because as we saw, there are some cool things about it, and there are also some flaws. So for me, the first thing is when you want to use the declarative framework and you want not only to render fast with server pre-rendering, but you want to also react fast with the JavaScript functionality. Because when you have the framework like React, and you can pre-render on backend as well, but anyway, your bundle can have 500 kilobytes of code, and until it's loaded to the browser, you cannot interact with the JavaScript-driven things. But here, you don't download the framework, so it's like super fast. We will later see some example how big the bundle can be. What we also saw in the game of life, like it's super cool for if you have so many bindings and you need to do fast things, fast transitions, fast animation, not driven by, for instance, CSS animations, but driven by like frame by frame animation by JavaScript. Then of course you can use something like, I don't know, Greenshot, which will help you, but it's already a third-party library. But if you want to use these direct animations in any framework like Angular, React, Vue, Ember, then it's actually slow, because the framework is not done for animations, it's done for presenting information on a screen. But with Svelte, it works, as you saw, like super fast. On this computer, it's like 100 frames per second with rendering very complex thing. You can create fast prototype without heavy coding, which we did actually in the last design sprint we had, because the customer wanted something what cannot be done as static pages or static presentation in Keynote or a Sketch or Figma or whatever. It just had to be HTML. So we did, and this was like, there is no overhead. As you saw, create component, it's like actually 0 line of code. It's just name of the file, and then if there is a hello in div, it's already component. You don't need to declare anything what you don't need. So it's super fast for prototyping, and it's also possible to create these custom elements or web components, as used to be called, which there are also some other frameworks dedicated directly to this issue. So maybe this is not the best solution, but it can do it as well. So once you learn it, then like, why to learn Polymer when you can do it with this, and it's a very similar result. So that's it for the use case. I will also do some showcases, as I said, but unfortunately this was done for a customer and we cannot stream it. So we will first have some small discussion. If you have some questions or whether it's told you if this is possible way where the framework will go. I can tell you in advance that the Angular IB is aiming the very same direction, that they see the future of Angular in a compiler. So they will just maintain the structure of the code. They will throw away the framework and use something similar to this. There will be more leftovers from the framework than in this case, because in this there are more or less none. We will see if React will go the same direction. They said they tried and it was too hard for the JSX to understand the compiler what's exactly happening, that they just gave up, but maybe there will be some smart guy coming and doing this as well. We will see. So it's time for questions.
I have a question. Have you tried it with like standard apps that are rendered, like just normal apps?
Yeah, I have some my own app I did in it, or I'm doing in it. It's very complex. It's like use a lot of this SVG animation. It has built-in 3JS configurator, and then of course if you load such a big library, then the bundle is huge, and you kind of lose the benefit of being that fast. But you see the benefit best when you have some kind of static pages, but you want the little bit of the dynamic stuff. Like if you have maybe something more than media houses do, maybe news are not that interactive. It can be even a little bit more. My feeling is that when the app would go, especially with the complexity too far, you will lose yourself in your code, because the framework is not really restrictive. It doesn't push you in some way which everyone understands. You can do it with native JavaScript. You can do what you want, and then this is the biggest problem. But yeah, I tried.
But I meant it more as for instance, if you take I don't know Facebook or something. So Facebook is more of a traditional server a served app, but then there's some small parts that are kind of interactive.
Yeah, I think that they could pretty much
is there firstly you'll make it work, but is there some standard way to do it easily that is kind of documented and you don't have to?
Yeah, it has cool documentation, which is very nice. It's not overloaded. There is just what you need, but it doesn't include the best practices. It just gives you explanation how it works. But I think it's similar with React. For me, the comparison between React and Angular is that React is faster, cooler. It has easier way to extend the things when you want something which is out of the box, but it doesn't tell you you should do it this way. And if there is some developer on average project doing it that way, and then come new one, it has hard time to understand the code. With Angular, it's the opposite. It's slower. You write more, but if new person come, and if the average app, it's not something super crazy like we did here with Access, for instance, then it's super understandable for everyone. You have zero ramp up for understanding the project. And here it's even worse than the React, I would say. Some other question, or can we go for some Slack questions?
So maybe I will have one more question. So you were talking about the bundle. So for instance, Webpack, that one big, if you compare Webpack to Rollup, for instance, that's a good example. The final bundle of Rollup is very slow, it's very small, and then one of the reasons is actually so Webpack generates, let's say, the way how you import modules and everything. So it gives the algorithm there, so you can use imports, let's say, in the browser. That makes it very, very, very slow. So I don't know how in here, when you said that there was those things with this folder structure and everything works, but how does it work here? How does it work that you would load things?
Yeah, the compiler it's itself, and I went through a little bit of the code, but it's super abstract, so I didn't want to spend with understand everything. but it also use either Webpack, rollup, or parcel for the creating the chunks of the code. But it's compiled in the Svelte compiler, and then it passed to the Svelte or to the parcel or Webpack, or there is that it's done in Webpack first, and then it goes back. It depends what you do. If you first need to parse the CSS, you first do it by the rollup, then you get the result in CSS, then you pass it to the Svelte compiler, and it's already do handle just the regular CSS. And that's the problem with the TypeScript.
I see.
That as they don't have own parser for TypeScript, they need to rely that someone else transpile it in the, I would say, not the right way, but way which doesn't bring unnecessary code which is then generated, because the Babel is way smaller difference between the ECMAScript next and the JavaScript 5 or ECMAScript 5, and with the TypeScript it can generate a hell lot of code for enumeration types and all this stuff are way more code.
Thanks.
Anything else, or we can stop the streaming and go for some showcase? Probably not. Maybe.
Yeah, yeah, that's sure. Can I have a question? Yes.
So what is it?
We are waiting, Gerda.
He's not writing.
He's not writing yet.
Yes, you can have a question.
Okay.
Okay. I cannot answer this question.
What's the question?
Sorry?
What's the question?
We are waiting for the question.
He said he will have a question, but
maybe just one small one. Do you have any idea of companies using it in production for some?
Yes, they are the author of the framework works for New York Times, and he actually started with this as the only Svelte for only components, and he wanted something fast for animations. That's what we saw with the Game of Life, and he really cared about this interaction animations by JavaScript because he was lead in the design, how to say it, data design or something. So it's showing charts or some data in very non-text or table way, and they want all the animations, and they find out that all the easy to write frameworks are just too slow for them. Yeah. So he created this, and it's worked very well. And now he is trying to work on something similar with this compiling tree shaking stuff with WebGL. He had some preliminary results, but I think that it will be quite simple, not for really complex solutions, because they want to do it real declarative. So even that you will be able to describe by kind of XML syntax, not writing the JavaScript. So you just, instead of div, you set sphere, and it will just give attributes like size and whatever. You give HTML element or light, and it will get light to the scene, which is pointing to the sphere and so on. So yes, it will be nice for his purposes of showing 3D graphs, but it won't be a solution for modeling 3D car, which is you drive in a game and so on. So
Yeah, there's a question.
the question is, stream the showcase as well. It's by Michal, unfortunately not. But I can show him later. In other, establish communication of the system with backend and get information from it. How good, bad is it next, for example, Angular? Okay, so I would say that it has pretty much same approach as all the framework. It just don't pretty much care about the backend. It's driven by API or GraphQL, it has some API like calls. It has its own implementation of like Ajax calls, and that's only done because when you again run it not in the browser but in Node.js for pre-rendering, not all the like calls for Ajax, all the attributes are the same, so they just needed to create its wrapper, which works either on front end or on back end for the pre-rendering. But it doesn't. It's actually, as you have the routes, you can name one of your routes in the folder structure with not like Svelte as a page, but as a JavaScript, and then you can use the endpoint as they like API endpoint.
Oh, yeah.
So that's something more which maybe compared to Angular, all the frameworks don't have anything like this.
Yeah.
This framework has, but I would say it's like for mocking, it's not really done for production, no one will use it.
So like I would say, the routing is very similar to static, like JQL, for instance. They have like very similar thing. If you want to have custom URLs, you have to play on the, like even you can customize it, or you have to play on the folders.
Yeah.
How you want to sort of.
So something more.
No.
Okay, so then we stop the sharing, and I will first show what